welcome to this week's episode of CAE Quick Tips. Today I'd like to show you how we can use Product Template Studio, or PTS, to capture and reuse simulation workflows. Today we'll focus on how we can modify and reanalyze a PTS part, and next week I'll walk you through how we create one. What we have here is an airplane wing flap assembly with an actuator subassembly that activates the aileron's motion. To illustrate this motion, let's just manually move the piston in and out. As you can see, by moving it back and forth, the aileron moves up and down. In this actuator assembly, this actuator arm is built from a part template and there is a requirement to change its design. By selecting the arm, we see that we have the option to edit reusable component, which indicates it's a PTS part. What we see here is a unique custom menu that indicates this part is comprised of 3 templates, with 2 nested into the other. As its name indicates, PTS requires a part with well-defined features to form a template. Here we open the torque arm template and get a dialog with 2 fields. We are essentially only exposing one driving dimension, the arm length, to the user, and as it is increased or decreased, the weight of the part is recomputed. If you notice in the status bar below, the part is being re-updated as we change the arm length. In this case, we'll settle on an arm length of 4.8 inches. Now we can go modify one of the 2 CAE templates, in this case the bending load FEA. Here too we have a dialog that exposes only the subset of an FE model. Again, because this is a template, it has underlying parts, but for a simulation, these are the FEM and SIM files. As with standard FEMs, by modifying the design, the polygon body needs to be updated to accommodate the increased length of the arm, and this has been automatically done. The user then has one variable, which is to set the perpendicular bending force, and then to solve it. We can then view and animate all the results as we would with a standard simulation file. The key takeaway is that when you have a well-defined and repetitive workflow, PTS gives you the ability to embed knowledge into your parts and only expose specific information that you modify and validate within a range of values. From a CAE perspective, this allows you to free up analysts' time and enables designers to do simulations within these limits. Now that you have seen how this works, next week I'll show you how we can quickly create one, so please tune in. As always, if you like this video or have any feedback, please let me know below.